Hi, everyone. Welcome to the third lecture video of week one for EG1311 Design and Make. In this video, we're going to be talking about all the materials we're going to be giving you for you to build a robot when you're working on your project. So you'll receive all those materials at the beginning of your first tutorial, either in week 2 or in week 3, and we'll give you generally 4 bags of materials, and 2 of them will be the same with electronics kits, right? And these will have things like your Arduino, the motors, the sensors, things like that. And we're giving you 2 sets of them so your group can work on the project in parallel on different parts of the robot, or you can even build 2 robots at the same time. Suffice it to say that you only need to build 1 robot on the course at the end of term. So that's the electronics kit. We give you 2 copies of that. And then a tools kit, which will have things like the battery charger, a pen knife, a hot glue gun, those kinds of things. And then a materials kit that has kind of the raw materials that you'll use to make the structure of your robot. Things like a polypropylene sheet, a piece of foam core, rubber bands, popsicle sticks, things like that. And really only things that we're giving to you in tutorial 1, those are the only things that you should be using on your robot for the graded run in tutorial 5. Now, you're welcome to use outside materials before that for prototyping and testing. Of course, we're not going to reimburse you for any of those kinds of things, but you can't have any of those extra materials on your robot for the graded run. That's the limitation to make it fair for everyone in terms of having a constrained amount of resources when building this robot and tackling this design challenge. Now, there are a few exceptions. If you want to use additional adhesives like glue or tape that are different from the ones that we're giving you, that's fine. We're only giving you masking tape and hot glue, but if you want to use something like epoxy or scotch tape or other adhesives, that's okay. Of course, we won't be able to reimburse you for anything like that, but you can use them if you'd like. Additionally, you can use as much paper as you'd like, which can be a great material to make lighter weight structures. Lastly, there are paper clips in the lab that you can use. They won't be part of your parts kits, but you can just ask the lab staff if you want to use them. You can use as many as you like, but you can't use outside paper clips. You can only use the paper clips that we're giving you in lab. You can also draw or print on any component of your robot that does not need to be returned at the end of term. Those are the exceptions of materials and modifications to the parts that we've given you that you're allowed to use. You're not allowed to 3D print pieces and add them to your design. You're not allowed to laser cut on material other than the laser cutting material that we're allowing you to laser cut in tutorial. So don't go try to find some other lab to do laser cutting or 3D printing outside of your lab time, because you're not allowed to use them on your graded run of your robot anyway. So teams are responsible for keeping your materials well between tutorial sessions and bringing those back. So please do assign someone in your group each week to keep track of the materials. And I'll note that some items in your kit, they've been used in previous terms, but also even new components that we might get from our vendors have been broken in the past, right? And so we are not able to fully vet every piece of material between semesters for all 200 kits that we produce. It is your responsibility in your team to identify if one of your sensors or motors or anything like that are broken. If they're broken, just find one of the lab staff and we're happy to replace them for you. But we can't help you unless we know that those things are broken. So please ask for an exchange if you think they're broken. And it's important that you show us what the problem is when you think your parts are broken, because more often than not, your parts are not broken. They're just being misused in some way. So it's important to show us so that we can help you debug. Okay, so now let's talk about the specifics of what's in each of these kits. Toolkit has your battery charger. We're giving you 2 sets of batteries in your kits this year. And that's just because sometimes your batteries discharge and it's good to have a spare. Or if you're working on 2 robots in parallel, you'll have access to being able to use those batteries. However, this is the one exception where we don't want you to use both 9-volt batteries or both sets of AA batteries on your robot in tutorial 5 for the graded run. That's more power than you need, and the design challenges, you can use
exactly
one 9-volt battery
and exactly 6 AA batteries
on your course in tutorial 5. So that's the one exception. Otherwise, you can use all of the materials that we've given you on your final robot, except for this condition on the batteries. So we'll also give you a hot glue gun along with glue that'll be in your materials kit, an A4 cutting mat, a retractable pen knife, a 30 centimeter steel ruler, and a ping pong ball. So the 30 centimeter steel ruler is good to check your robot on whether it's satisfying the length requirements, the volume requirement for fitting in a 30 centimeter cube when you're running on the course. And the ping pong ball is what you'll be delivering over the wall at the end of term. So that's the tools kit. Please keep in mind that these rechargeable batteries actually take quite a long time to charge, like on the order of 10 to 12 hours once it's drained to be fully charged again. So really, there should be never a situation where it's actually useful to charge your batteries in the lab, because a 2-hour lab session is really not going to put any dent in charging up your batteries. So what I would suggest you do, whoever's in charge of the battery and the battery chargers each week, you just have them charge the batteries at home overnight, and they'll be all set for when your group meets again on the next week. So for the tools kit, we need all of these parts back because we reuse them from term to term. Whereas for the materials kit, we don't need any of this stuff back. So that's what this, kind of asterisk is on the side, on the left here. These are saying that we don't need these back, right? And so in your materials kit, you've got a 0.5 meter by 0.5 meter, 2 millimeter thick cardboard, one sheet of that, an A4 2 millimeter thick polypropylene sheet, slightly thicker 5 millimeter foam core sheet, a piece of anti-slip mat, a roll of masking tape, popsicle sticks, some 3-inch diameter rubber bands, and some glue sticks. So all of these things we don't need back at the end of term. That said, you have a limited amount that we've given you, and you cannot exceed that amount for any of these materials except for 2 exceptions. The cardboard, we have basically unlimited cardboard. You can use as much cardboard as you want, and glue sticks. You can ask the lab staff for more glue sticks if you run out. Other than that, you're limited to at most 20 popsicle sticks on your robot. You're limited to at most 10 rubber bands, et cetera, et cetera. A note on the sheet material that we're giving you, the cardboard and the polypropylene sheet, they're corrugated materials, which means that, as you kind of see up here, corrugated materials have a layer on top and a layer on bottom, and then kind of a folded sheet in between that provides a separation of the 2 layers and provides structural rigidity. Those corrugated materials are very light for their thickness, but as you can see, because of the nature of this folded material in there, it is an anisotropic material. It is not the same in all directions. If you try to bend cardboard with a fold along the grain, it will actually bend very easily. Whereas if you try to fold against the grain, it will actually be a little bit more difficult, much stronger resistance to bending. So that's something to take into consideration when you're modifying and working with this material with your penknife or bending it to make more rigid structures. I would suggest when you're working with this material with your penknife that you cut against the grain first, because those will be harder cuts to make than cutting along the grain. And be careful with your penknife because your penknife has an angle to its blade. And so if you're cutting into the material from above, just be cognizant that the amount that you're cutting on the top of the surface may be different than where the blade is on the bottom surface. So just keep that in mind. If you're using printed paper templates like we're asking you to do for the template project, if you're designing a pattern to cut in CAD and then printing out that template, just make sure to print that template to 100 scale, and then you'll transfer those dimensions correctly to the sheet material that you're going to cut. Tape those templates onto the sheet material that you're cutting, and then cut through both layers. That'll be a lot easier than trying to estimate the alignment between these two layers. So that's corrugated material. Then the last material that you have access to, you will not be receiving in tutorial 1 with all of your other materials. You will have access to cutting plastic parts from acrylic using the laser cutter. And you'll be allowed to do laser cutting in tutorials 2 through 4 after we've released the videos for how to make CAD files using Fusion 360 that the laser cutter will be able to read and cut your parts from. You'll have access to 3mm thick black acrylic. It's the same material that your couplers that are in your electronics kit will be made out of, which we're going to talk about in a second. But we'll be talking all about laser cutting starting in week 4. You don't need to worry about that now. So moving on to the electronics kits, you're going to get 2 of these, remember. So on this page, we see that you're going to get an Arduino Uno, 1 Arduino Uno per kit, along with a USB cable, USB-B to USB-A. So this is USB-B that'll go into your computer, and this is USB-A that'll go into this USB port on the Arduino. Then you'll have 2 geared motors per kit, and these are at a pretty high gear ratio, which we're going to talk about the next week. And 2 battery holders, one for your 9-volt battery and 1 AA battery pack holder for your AA batteries. And then these are motor couplers, which are a little plastic part that we cut out of the black 3mm acrylic. We laser cut these to fit on the end of this motor shaft, because if you were to try to attach, say, a cardboard wheel onto the end of this motor shaft, it would not be able to transfer torque. And so what we do is we put a stiffer material on that motor shaft, like acrylic, which will then be able to have a larger structure that we can attach the cardboard to, which is not going to rip the cardboard. Okay, so those are the first set of materials in your electronics kit. Second set of materials that are in your electronics kit are a servo motor, a breadboard. We're going to talk about how all these things work in week 3. The servo motor is really nothing more than a motor with a little sensor on there to tell us what angle the head of the motor's on. The breadboard is a little prototyping board that makes electrical connections within the board itself so that you can easily make connections via jumper wires. And these are jumper wires. They have a little rigid wire coming out of it that you can use to plug into these breadboard holes. These are called male ends of jumper wires, whereas the socket here on the breadboard, those are called female. And so what you do is you plug the jumper wires into the breadboard to make connections to the rest of your devices, like the Arduino, the motors, the sensors, etc. Now, in addition to the male-male wires here, we're also giving you male-female ones that have a female socket at the end, which, can be helpful if you're trying to make an extension for a wire. You can combine a male-male and a male-female wire, or you can use it to plug into things like the ultrasonic distance sensor or the H-bridge. You can use, instead of plugging those things into the breadboard, you can use the female ends of these jumper wires to make connections. So with the servo motor is a coupler pack, very similar to the couplers that we are giving you for the yellow gear motors. And then we have a sensor, which is essentially sound microphone that's going to be able to tell your robot how far something is in front of you. It works kind of like a bat in echolocation, right? What it does is it sends a sound wave out and listens for how long it takes for that to come back. And from the speed of sound, it's going to be able to interpret how far away something is in front of it. So that's the ultrasonic distance sensor and the H-bridge motor driver, which is going to allow us to turn on and off the motors from our Arduino, because it's actually difficult to do without a motor driver. So we're going to be talking about all this stuff in next week and the week after. Suffice it to say that you won't necessarily know what all of these things do when you're working on your template project in tutorial 1, but you should be all set with understanding those things by the start of tutorial 2. And so the hope is that you'll be done with your template project by the start of tutorial 2. So those are the parts that we're going to be giving you in tutorial 1. Please stay for a brief quiz.